Okay, so in this video I'm just basically gonna derive a formula for how to get the volume. So the disk method, you're gonna have a formula written by something like this: pi multiplied by the radius multiplied by the integral, the definite integral of the square of the radius. When you have something like this means that you are it's gonna be dx. So let me just write y here, y dy. This technically means, or this technically implies that we are rotating around the vertical axis, around the y-axis. So that means you are rotating about the y-axis. And then r at y will be when we technically solve for x from there. And r at y will be technically when we solve for x, because we are rotating about the vertical axis. And then that technically implies that our radius will technically be along the x-axis like this when you rotate this, when you rotate that. And then you can see that your radius will be the x value, and that x value will be when you solve for x on that function that's provided. So now I'm just gonna do a quick derivation of let's start with a cylinder, right? Let's start with a cylinder, something like this. Let's start with deriving the volume of something like this. Let me just show it like this. Yep, the volume of something like this. A cylinder with radius r and height h. So what you're gonna do here is that you're gonna let me just represent this on a Cartesian plane there. So we're gonna have a vertical line, x equals r. We're gonna have a vertical line, x equals r. This will be a line defined by x equals r. And then we're gonna have a horizontal line defined by y equals h. And then you're just gonna have an intersection coordinate r is to h. And then from here we want to find the cylinder, the volume of a cylinder. Notice that we're going to rotate this about the vertical axis, so that means that we're going to use this formula. So the volume of that cylinder will technically be pi multiplied by the integral. Remember, we're moving from 0 to h, where y is just h here, from 0 to h. And our radius r at y will just technically be r, because x is just r, right? And then don't forget that the formula has a square in it, and then dy, because we're rotating this about the y-axis. Then when we do that, we're gonna have a figure like this. And then from then that means we have pi, and then we have r square here. R square is just gonna be constant, so you can take it outside the integral, and then you have integral from 0 to h dy. And then integral dy, we just know that that's just going to be producing y, and we're evaluating y from 0 to h. And then that means that we're going to have pi r square into h minus r 0, which is just going to be h here. So that means the volume of that will just be pi r square h. So that's the volume of this. So I'm going to be quickly deriving other formulas as well, but this is just an idea of what's happening. But then if we were rotating about the horizontal axis, we will have solved for y instead. Thanks for watching. Don't forget to share and subscribe.